Show that the given differential equation is homogeneous and solve each of them. X square plus x square dy is equals to x square plus y square dx. The differential equation can be written as dy by dx is equals to x square plus y square upon x square plus xy, right? We just put it in the right side and this in the left hand side. So now we consider f of xy to be this term, that is x square plus y square upon x square plus xy. Now f of lambda x comma lambda y will be lambda x the whole square plus lambda y the whole square. Just substitute x as lambda x, okay, and lambda x the whole square plus lambda x into lambda y. Okay, now if we consider, so it will be lambda square x square plus lambda square y square upon lambda square x square plus lambda square xy. So if we take lambda square common, so it will be lambda raised to 0. So x square plus y square upon x square plus xy will be the answer again, is equals to lambda raised to 0 f of xy. Therefore, it is a homogeneous equation, right? To solve it, we will put y is equals to vx. So now differentiating both the sides, we get dy by dx. With respect to x, we have to differentiate. So it will be dy by dx is equals to v plus x dv by dx. Okay, this is a chain rule. Okay, v plus x dv by dx. Substitute this equation in value in equation 1. We'll get v plus x dv by dx. Dy's value will be v plus x dv by dx plus put y in terms of put vx in place of y. So x square plus vx square upon x square plus x vx. Okay, so v plus x dv by dx is equals to 1 upon v square divided by 1 plus v square divided by 1 plus v. Okay, so after that x dv by dx will be equal to, put this v on the right hand side, so it will be minus v and then cross multiplied by 1 plus x 1 plus v. So it will be 1 plus v square minus v 1 plus v upon 1 plus v. So if we calculate this, we will get 1 minus v upon 1 plus v. Okay, so 1 minus 1 plus v, so we'll put this term on the left hand side, so it will be reciprocal, and we'll put dx and 1 upon x on the right hand side. So 1 plus v upon 1 minus v dv is equals to dx upon x. Okay, so if we just take it, just give it on different sides, and if we take the LCM, we'll get 2 upon 1 plus v minus 1 dv is equals to dx. So what do we do is here, if we cross multiply this, that 1 minus v into minus 1, okay, and then add with 2 minus 1 upon v. So basically if we cross multiply this, so we'll get this term. Okay, so that's what we have done here. So integrating both the sides, we get minus 2 log 1 minus v is equals to log x minus log k. So v is equals to minus 2 log 1 minus v minus log x plus log k. So v is equals to log k upon x 1 minus v the whole square. Again substitute the value of y is equals to v upon x. We get y by x. V is equals to y upon x here. So this is a mistake. So y by x is equals to log kx upon x minus y the whole square. So kx upon x minus y the whole square is equals to e raised to y upon x. Just we have put the log here, so it will be e raised to this term. So x minus y the whole square is equals to kx e raised to minus y upon x. Okay, we have took e raised to y by x term on the left hand side, so it will go in the denominator. That's why it's minus y. The power is minus. Okay, if we take it in the numerator. So this is the required solution of the differential equation.